Imagine your phone dies and you have to borrow a friend's device to log into your bank account. You probably feel a slight hesitation before typing your password. You trust your friend, but you don't necessarily trust the invisible software or the hardware running inside their device. Handing over your private information feels risky when you aren't the one in control of the environment. Take that everyday human anxiety and scale it up to the size of a trillion-dollar company. Apple has built its entire reputation on privacy, promising that you are the only person who can see your data. But there is a complication. Apple's newest AI tools are so massive, they require specialized supercomputers to run. To make it work, Apple is now renting space inside Google's data centers, using hardware they don't actually own. This creates a difficult puzzle. How can Apple send your most private data into a rival's building without letting the landlord see a single bite of it? They solved this by demanding a setup where Apple gets all the computing power it needs, but the people who own the computers are completely locked out of the system. In a traditional cloud setup, your data travels securely in a digital safe, but that safe has to be unlocked to be processed once it reaches the server. For a split second, the data is exposed inside the computer's memory. Apple's requirement for this partnership is a standard called Zero Operator Access. Under this system, the digital safe stays closed. The information remains fully encrypted and hidden even while the server is actively working on it. This happens inside a trusted execution environment. Think of it as a specialized armored room built deep inside the server. Data goes in, the work gets done, but the rest of the server is kept completely in the dark. This isolation is built into the physical, microscopic boundaries of the silicon chips themselves. Because the lockout is physical, a Google engineer could be standing right next to the machine with full administrative power, and they would still only see scrambled mathematical noise. Apple doesn't just take Google's word that these armored rooms are working. The system requires mathematical proof before any information is ever sent. They use a hardware ledger, which is a public, unchangeable list. It tracks the exact identity code of every single authorized piece of equipment inside the Google data center. Before your iPhone sends the authorization to read your request, it independently verifies the server's identity against this public list. It makes sure the machine on the other end is exactly what it claims to be. If the machine fails this check, perhaps because a component was swapped out or tampered with, your phone refuses to talk to it and keeps your data local. Once the computer finishes the task, it forgets everything immediately, wiping the slate clean and leaving no logs or saved files behind. This design puts the user's device in charge. Your phone decides who to trust based on math, rather than the cloud provider deciding what they can see. The result is a system where privacy is based on mathematical certainty rather than corporate promises. For years, using the internet meant trusting companies to be responsible with our data and hoping their system administrators didn't use their all-powerful permissions to look at things they shouldn't. This partnership demonstrates that even the most powerful AI can run on a system where administrators have no special privileges and no access to user information. This technology is also becoming more accessible. Google recently released these tools to the public, allowing any developer to build the same kind of secure connections Apple uses. The focus is shifting from trusting the reputation of a tech company to trusting open, verifiable mathematics. So the next time you ask your phone a personal question, you can know that a system of mathematical safeguards is working in the background to keep your secrets safe.